So, good evening, dear students. Today we will, continue from mean deviation for continuous frequency distribution. Now, before I proceed further, could you please confirm that you are able to view my screen properly and able to hear my voice very clearly?
Yes, sir.
Okay, great. So, hello, Srijita. Able to hear my voice very clearly? Able to view the screen properly?
Yes,
Okay, great. So as I was telling that today we will start, from that discussion on mean deviation for continuous frequency distribution. So the given data is, is in a series in which the data are classified into different class intervals without gaps, along with their respective frequencies. And we can calculate the mean deviation about mean, okay, for continuous frequency distribution based on the following formula, as I'm going to show it to you now. So the way we are going to compute the mean deviation, about mean for continuous frequency distribution is like this. Okay, so how we get it is that it is a mean deviation about mean. So that is, as you see, that mdx bar, and that is equal to summation of fi into mod of xi minus x bar divided by capital N, where capital N is equal to summation over fi's from I equal to 1 to n. So this is the formula for mean deviation about mean. So what we will do to students, that first we will take an example, okay, and to show you that how we are finding it. And when you find it, you will find that it is a very tedious task. And as it is a tedious task, then we can find a more shortcut method to find the mean deviation about median for continuous frequency distribution. Now, to understand that why we should use the shortcut method, which is the next formula I'm going to give. But before that, we need to first make an example to understand how tedious is to compute what to compute that mean. That x bar computation is actually tedious process in according to this formula. So then what we will do, we will find a way where we no need to find that x bar in this tedious manner. So for that, let's first take an example. Okay. So for this example, so let me first give you that example here, and make it available in front of your screen, and here it is. So as you look into the data set, that finding mean deviation about mean for continuous frequency distribution is that, while calculating the mean of a continuous frequency distribution, we assume that the frequency in each class is centered at the midpoint. Okay, that the frequency in each class is centered at its midpoint. That means if you see the class interval is that 0 to 100, and what is the example? It is income per day. So 0 to 100, there are 4 persons having income 0 to 100. Then 100 to 200, it is 8. Then 200 to 300, it is 9. In that way, it goes till 700 to 800, 3%. Okay. Now, what we are going to do, we are going to calculate the mean of this continuous, mean deviation about mean. We are going to find it out. So now, for that, what you need to find, if you remember from our last class, okay, is that we need to form a table, because all these values you need to compute. No, if you remember this, this formula, all these values you need to compute. So to compute all these values, fi, xi minus x bar, then their absolute value, and we need to divide it by n. Okay, so fi, all you need to write in a column, row and column manner, that is in a matrix form, and then from there we can compute it. So how to form that matrix one? Let me show it to you, dear students. So So now, as we assume that the frequency in each class is centered as its midpoint, we form the following table. Okay. So income per day 0 to 100. What is the midpoint is 50. 100 to 200 midpoint is 150. 200 to 300 the midpoint is 250. Okay. And in that way, we proceed 200 to 300 midpoint is 250. 300 to 400 midpoint is 350. 400 to 500 midpoint is 450. 500 to 600 midpoint is 550, like this. 650 and 750 as well. And we know from that table we know the frequency, right? This from this table we know the frequency. So what you need to compute? Fi into xi. So Fi into xi, so 50 into 50 and 4 we multiplied, we got 200. Similarly 150 into 80 we got 1200. Like this we found that Fi xi. And x bar we can find it out, dear students. Okay, x bar, as you know, that we need to sum all these things, that 17900 divided by 50, that is the x bar. Correct. So that is a tedious process, what I was telling, because you need to sum all these things, all these values. Correct. That you get 17,900, and that you need to divide by these values. Okay, which is sum of these values, that is 50. Okay, so 17900 divided by 50 is the mean, and that is equal to 358, and that is why we wrote the mean. After that, you need to compute that x minus x bar, and we know all these things how to compute, and you need to take their absolute value, that is x minus x pi, modulus of x minus x, xi minus x bar, and then you need to multiply it by with that mod of xi minus x bar with fi, and then we get the value at 7896. Okay, sum of all those values. And then, dear students, that we can find the mean deviation about mean by means of that formula, whatever we just discussed at the beginning of the class, and we find the mean deviation about mean is like this. So what we get is that mean deviation about mean, we get this value. Mean deviation about mean, we get the value as summation of fi into xi minus x bar divided by n, and we get that value is equal to 175.92. Now, dear students, as you see, it is little tedious process to compute the value of the mean. There is a shortcut method, and I am going to tell you that shortcut method first, and then we'll make one example to understand that how it is helpful. Okay, so what is the shortcut method for calculating mean deviation about mean? And here it is. Let me go to the next page and explain you. So this method of computing that mean is known as the step deviation method. Okay, and sorry, it is known as the step deviation method. Once the mean x bar is calculated by step deviation method, the rest of the procedure remains the same to compute mean deviation about mean. Correct? So the tedious process of computing x bar can be reduced by following the step deviation method. Okay, what is that method? Let us find it out. So in this method, we assume the values of the following two items. The first one is that assumed mean. That is, we denote it by A. Assumed mean is A. It is the middle value or just close to it in the data. Whatever the given data set is provided, it is just a middle value or just close to it in the data. And the second one is that common factor, that is H. There is a common factor. So there are two assumed values. One is A, that is the assumed mean, and another one is H, that is the common factor. Now, by means of these two items, the mean of the data x bar is computed by means of the following steps. The step one is that compute di. Di is nothing but, dear students, it is xi minus a by h, for I is equal to 1, 2, 3 up to n. And what is step 2 is that x bar that is equal to a plus, that is that assumed mean, plus 1 by n into summation of fi into di, and then that summation is multiplied by h. So these two steps will give us to find the value of the mean in little easier manner with respect to the previous methods what we have discussed few minutes back. So this method of computing x bar is known as step deviation method. Once the mean, that is x bar, is calculated by step deviation method, the rest of the procedure remains the same to compute mean deviation about mean. How? Let us take an example to understand. Okay, so let us first uh, uh, place the question, and you see the question in the next page, dear students. So let me make it visible to you. So here the example is, dear students, that the data set is given and the frequency is given. So data set is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. And all these, intervals is coming into this frequency. So 10 to 20 with frequency 2, 20 to 30 with frequency 3, 30 to 40 with frequency 8, 40 to 50 with frequency 14, 50 to 60 with frequency 8, 60 to 70 with frequency 3, and 70 to 80 with frequency 2. Now, let us find the mean deviation about mean for the following data set with assumed mean as 45. That is the A, right? Remember, dear students, that few minutes back I said assumed mean, that is A. A is equal to 45 and common factor is 10. That means what? What you can say is that here A is equal to 45 and H is equal to 10. Correct? Now, dear students, is that according as A is equal to 45 and H is equal to 10, so we construct the following table towards computing the mean. So what is the table? So table, let me place in front of you, and you can also do at your end, dear students, and you'll find the same value. So as you see that data is 10 to 20, frequency is 2, and its midpoint is 15. Okay, so midpoint 15, 20 to 30 midpoint is 25, 30 to 40 midpoint is 35, 40 to 50 midpoint is 45, 50 to 60 midpoint is 55, 60 to 70 midpoint is 65, 70 to 80 is midpoint is 75. And their respective frequencies are given 2, 3, 8, 14, 8, 3, 2. So then, according to the shortcut method, we need to first find that di. If you remember, dear students, in the previous page I explained what is di. Di is this one, that xi minus a by h. So here it is the di, that is xi minus a by h. And if you know xi, you know a, that is 45. You subtract and divide it by h, that is 10, and you will get these values. These are the values of xi minus a by h. And then we multiply this value di with the respective frequency. Frequency here is that fi, correct? So 2 into minus 3. So 2 and minus 3 will get multiplied, we get minus 6. 3 and minus 2 get multiplied, we get minus 6. 8 and minus 1 get multiplied, we get minus 8. 14 and 0 is multiplied, we get 0. 8 and 1 we multiplied is equal to 8. 3 and 2 multiplied, we get 6. And 2 into 3 is multiplied with 6. So you get 0. Correct, dear students? So now,
Yes.
okay, great. So now what you can find, dear students, here is that we can find the mean very clearly, very easily, and it is a quite easy process to find the value of the mean. And how to find the value of the mean, dear students? Here it is. So as you see that we find the mean x bar is equal to a plus 1 by n into summation of fi di into h. So, as you see that a is equal to 45, okay, and n is equal to 40, 1 by 40 into 0 into 10. So that becomes ultimately 0. The second expression becomes 0. So finally we get the value of the mean as 45. Once the mean is computed, dear students, then the process is quite straightforward. Okay, now we can compute the mean deviation about the mean based on the same process what we have learned earlier. Whatever we have done in the last few minutes is to compute the value of x bar in a little easier method using the step deviation method. So as you see here, dear students, that we compute the value of all these attributes, right? Frequency is already given, the midpoint, x minus x bar we know that is 45. Then we find the absolute value of xi minus x bar, then fi into absolute value of xi minus x bar, and we finally get all this summation of these values is 40. Okay, dear students, and then what you do is that mean deviation about mean that we get is equal to 1 by n into summation of I equal to 1 to 7, because there are 7 data points here, 7 values are given, and we compute the value is something like this. Okay, dear students, I hope things are absolutely clear.
Yes, sir.
Okay, now the next point, what we are going to do is that to find the mean deviation about median or continuous frequency distribution. So we are going to find the mean deviation about median for continuous frequency distribution. So how to find it out, that I'm going to explain you now. So mean deviation about median for continuous frequency distribution. The process of finding the mean deviation about median for a continuous frequency distribution is similar to process of finding the mean deviation about mean. The only difference lies in the replacement of the mean by median while taking the deviations. As simple as that. So how to do this thing? So there are a few steps, dear students, and I'm going to explain you those steps one by one. So let me first place it in front of you. So step one, dear students, is that the data is first arranged in the ascending order. Then step two is that identifying the class in which the median lies, known as the median class. Median class is the class interval whose cumulative frequency is just greater than or equal to n by 2, where n is the sum of the frequencies. Okay, I hope you got it, dear students. I repeat once more. Identifying the class in which the median lies, known as median class. We'll see by means of an example. The median class is the class interval whose cumulative frequency is just greater than the or equal to n by 2, where n is the sum of the frequencies. Once these first two steps are done, then we need to find four values. And what are those values, dear students? The values are something like this. So, what are the values we are getting? We need to find So we need to find the value of L, F, H, and C. What is L? L is the lower limit of the median class. Very simple to find. The moment we know what is the median class, you need to find the lower limit of that median class. Then F is the frequency of the median class. H is the width of the median class. And capital C is the cumulative frequency of the class just preceding the median class. Clear, dear students? Once these four values are done, okay, then we can find the median just by means of this formula, what I'm going to place in front of you. So M is the median and obtained by using the following formula. M is equal to L plus N by 2 minus C by F into H. Okay. And you know, dear students, as I said, we need to find the value of L, F, H, and C. And N we already know. Then it is very easy to find the median. Whatever we have done in these four steps is to find the value of the median. Once the median is found, then it is a very easy steps to find the mean deviation about median. We have done it for the discrete frequency distribution. It is in the similar manner. Only thing is that when you find the mean deviation about mean in that same formula, only thing is that in that case the mean is actually replaced by median. So once the median is found, the mean deviation about their median, denoted by capital M, and the entire thing is denoted by MDM, that is mean deviation about median, is computed by summation of Fi into mod of Xi minus M divided by N, where N is equal to summation of the frequencies from I equal to 1 to N. Now, dear students, let us understand all this, whatever we have learned, that mean deviation about median for the continuous frequency distribution, by means of an example. Okay, so to give that example, first we need to provide the table, okay, which is we define as a data set, and here it is, dear students. While calculating the mean of a continuous frequency distribution, we assume that the frequency in each class is centered as its midpoint. Following is the table describing the income per day for a set of 7 people in this case. Okay, not 7 people, sorry, the set of people. So there are 7 different classes: 1, 2, 3, 4, 5, 6, 7, 8. Not 7, it is 8. 0 to 100, it is 4. 100 to 200, it is 8 people, 8%. 200 to 300, 9%. 300 to 400, 10%. 400 to 500, 7%. 500 to 600, 5%. 600 to 700, 4%. And 700 to 800, 3%. Now, what we are going to find? We are going to find the mean deviation about median for this given data set. Now, as we assume that the frequency in each class is centered as its midpoint, we need to form the following table. And the table, dear students, we have formed this kind of table several times, during our session on statistics. So you will find it comfortable when I place the table in front of you. And dear students, during practice, solving the numericals, all you need to do is to compute this table properly. Any mistake in finding the table will lead a wrong result. Okay. So midpoint we found 0 to 100, midpoint is 50, 100 to 200, 150, 200 to 300, 250, 300 to 400, 350, 400 to 500, 450, 500 to 600, 550, 600 to 700, 650, 700 to 800, 750. and number of persons, that is the frequency, it is provided in this column. Then fi into xi, you can find it out. X bar, we already found it out. That is, the mean, we already found it out previously by means of, oh, I'm sorry, just a minute. I think I gave a wrong example here. This is not the example I wanted to give. I wanted to give a different example. Sorry, ignore this one. Sorry, I do not want to give this example. Yeah. So this is the right example in context to the discussion what we are having now. That finding the mean deviation about median for the continuous frequency distribution. So let us calculate the mean deviation about median age for the age distribution of 100 persons given in the table. As you see, age 16 to 20, it is 5 a person, 21 to 25 6, 26 to 30 12, 31 to 35 14, 36 to 40 26, 41 to 45 12, 46 to 50 16, 51 to 55 is 9. Now, first of all, let us find the cumulative frequency as below. So what is the cumulative frequency? So we found the cumulative frequency just like this. Okay, all of you are aware of finding the cumulative frequencies. Okay, so but still I'm just iterating once more. So here it is 5, then 5 plus 6 is 11, then we get that 11 plus 12 is 23, then 23 plus 14 is 37, 37 plus 26 is 63, 63 plus 12 is 75, 75 plus 16 is 91, and 91 plus 9 is 100. So this is the cumulative frequency. Now, dear students, what we get, capital N is equal to 100. So we get the median class as the class interval in which the cumulative frequency is greater than or equal to n by 2, that is 50. Which is this one? That is the 36 to 40. Correct? So this is the one, this is the main point of this thing, that is the one. Correct? So let me first so as you see, dear students, so we get n is equal to 100. As n is equal to 100, so we get the median class as the class interval in which the cumulative frequency is greater than or equal to 50. Which one, in which class interval that cumulative frequency is greater than or equal to 50? That is 63. This one. 36 to 40, that is, this is the class interval. So now we need to find all these four values L, which is the 36, in the 36 to 40, which is the lower limit. So if I can bring that formula once more so that you can understand. So what is L? The lower limit of the median class, correct? So let me place it here so that you can resemble that how these are actually being found it out, right? So L, we found that median class, that is the lower limit of the median class, that is 36. F is the frequency of the median class. What is the frequency of the median class? That is 26. That is the frequency of the median class, that is F. What is H? H is the width of the median class. Width of the median class is 5. Okay, because 40 minus 36 plus 1, that is a 5, because 36 to 40, that width is 5, and capital C is the cumulative frequency of the class just preceding the median class, that is the 37. Median class was there before that. What is the cumulative frequency? That is capital C. Once we have all this data at our hand, then we can compute the value of the median very easily. That median is equal to L plus n by 2 minus C divided by F into H. That is equal to, if you compute all these values, we get the value of the median as 38.5. Now, dear students, once we get the value as that value is 38.5. Okay, now it is pretty simple to compute the table, what we have done many times today also and in the earlier class on statistics, and that will help us to find the value of the mean deviation of the median for the continuous frequency distribution. So how to compute this one? So here it is, dear students. So the class is 16 to 20 is frequency 5, all these things. Then this frequency 6, this frequency 12, 14, 26, 12, 16, and 9. These are the given frequencies as given in the data set. Midpoint we know. Okay, so that midpoint xi, we found it out. Okay. Fine. And then median, we just found it out as 38.5. Then you need to find xi minus m, then the absolute value of xi minus m, then fi into x absolute value of xi minus m, and then summation is 748. I am not explaining in details, dear students, because similar things we have done many a times. Okay. And now we need to compute the mean deviation about median. That is quite straightforward. It should be 748 by 100 in context to the question, right? So we compute the, yeah, correct. So this is the way we compute the mean deviation about median. So we are done with today's class. Before we start our next class, I just like to tell you there are disadvantages, the limitations of mean deviation. There are some limitations of mean deviation, and it leads us to discuss a new topic which we will discuss in the next class. But before that, I just would like to tell you that what are the limitations of mean deviation. And dear students, I'll really appreciate if you can experiment all this by solving numerical problems, that whether these limitations make sense or not. And if it is or if it is not, whatever it is, we can have a open discussion in the next class. So what it is, dear students, the limitation of mean deviation. In a data set where the degree of variability is very high, the median is not an effective central tendency. Thus, the mean deviation about median calculated for such dataset cannot be fully relied. That's the first point. Second point is that the sum of the non-negative deviations from the mean is more than the sum of the deviations from median. Hence, the mean deviation about the mean is not very scientific. Therefore, in many cases, mean deviation may give unsatisfactory results. Third one, last but not least, mean deviation is calculated on the basis of non-negative values of the deviations and not the true deviation containing negative values. Therefore, it cannot be processed for further algebraic treatment. So all these reasons, the three reasons what I said, dear students, you can experiment all these reasons by solving numerical questions as available in the online test platform at konarclasses.com. Now all these reasons implies that we must have some other measure of dispersion. This brings the concepts of standard deviation, another measure of dispersions, which we will be discussing in the next class. So, dear students, I cordially request you to please, complete those DPPs and submit it, before we start our class day after tomorrow, at 5:30 p.m. Thank you very much, dear students. We will conclude the class now unless you have any specific question for me.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.